Okay, welcome back. And continuing with sitting gills. Okay, we're looking at power generation. Okay, power generation. Okay, these are the things we've looked at previously already. Okay, electricity supply. Electricity is a relatively new source of energy. In 1831, Michael Faraday discovered how to convert mechanical power into electrical energy. The first practical application was a lighthouse in 1856. It was not until the 1880s that power was produced commercially. At the turn of the 20th century, the full benefits to industry were realized. In 1916, the power stations were linked together and the national grid came into being. Electrical power in the UK is produced from seven main sources: coal, oil, gas, nuclear, hydroelectric, solar, and wind. Producing power. Coal, oil, and nuclear energy all heat water up until it is high pressure steam. This steam then drives turbines, which in turn drive generators that produce the electricity. Turbines are the mechanical way of converting steam into rotational energy. Generators convert rotational energy into electrical energy. Okay, and that's a block of diagrams here. Okay. Hydroelectric power. Okay, hydroelectric power plants are found in areas of high rainfall. They are placed beside rivers or within dams. The water is fed through turbines that turn generators that produce electricity, and this is the principle behind your hydroelectric generation. Okay, here you have 25 kilowatts, 25,000 volts, and then it's transformed up to the national grid of 400,000 volts. Okay, I think it goes up to 700,000 volts in certain places. But if you, as you transform the voltage to this level, from the top 1000 volts, you have very little current. So you could use smaller cables that could cover the country. So there's no way in the United Kingdom that you cannot get a decent power supply source. Okay. Pump storage generation. The water passes through the turbines in the same way, but the water is then stored in a lake further down the mountain. When there is a less demand, the water is pumped back to the top to refill the reservoir and then start the cycle over again. Okay. Now gas is burnt and the resultant hot gases are driven through the turbines to produce the electricity. They are popular for two reasons. They can be built smaller, they can be run up to full power much quicker than coal. Okay, well, I was just looking at something there, basically. Power generation, okay. Power generators have 3 coils, each produce a voltage. Each of these voltages are called lines, usually referred to as phases. They are given labels L1, L2, and L3. The phases are brown, black, and gray. That's correct? Oh, goodness me, it's okay. I was just thinking of red, yellow, blue then in my time for that at that moment in time. Okay, so forgive me, but as we know, it's brown, black, and gray. Okay, those are your phases. Okay, and let's go in a little bit, see if we can get that. Make sure you've got that in view. Okay, you can read it for yourself. Don't need me to be expanding on that in any way at all. Electromotive force, EMF. As the rotor turns within the magnetic field, a voltage is generated within the 3 sets of coils. 3 voltages are separated by an angle of 120 degrees. These are induced voltages and are the voltages supplied to the consumer. Okay. Alternating current AC. Alternating current is produced. Let's see if we just give you that close up on that. Okay. Come back a bit. So we get it into full here. Okay. Alternating current is produced when a coil is placed in a magnetic field and allowed to rotate. And this is all what happens here. This is just a simplified version of on a smaller scale, but this is done on a massive scale in regards to power generation. The coil is free to rotate within the magnetic field. As the coil turns, current is induced in the coil. This is tapped off at the slip rings. Current in the coil varies depending on how much of the magnetic field is being cut. Okay. Sinusoidal waveform. The coil stands at a position where no magnetic flux is being cut. The magnetic flux is shown by the lines between the magnets. At this point, if we were drawing a sinusoidal wave or sine wave, this would be the 0 on the waveform diagram. Line of flux, rotation, okay. Single loop coil, okay. That's going away from you, that's coming towards you, okay. 0, we're beginning to cut flux, and we cut maximum flux at this point. Now, peak-to-peak values, each part of the cycle above the 0 is called a positive half cycle, and each part under the 0 line is called the negative half cycle. Positive half cycle, negative half cycle, okay? And that is your maximum value, periodic time. From the 0 line to the peak of one of the half cycles is the peak value. From the peak of the positive half cycle to the peak of the negative half cycle is known as a peak-to-peak value. Because these peaks are not semicircular, the values are hard to work out, but we've done that before by putting lines of calculation, and you've seen this already on one of my videos, so please refer to that. Okay. Frequency, each complete wave is called a cycle or period. The quantity of cycles in 1 second is called the frequency. T equals 1 over f, f equals 1 over t, where t is time in seconds, f equals frequency in hertz. Each cycle or period lasts for a certain amount of time. This is usually measured in seconds or milliseconds. Okay, I hope you found this useful. Have a good day. Bye-bye.